This is 1.2 petabytes of hard drives, all connected to a single Raspberry Pi. In my last video on the PetaPi, that's what I'm calling it now, I got the whole thing working, but just barely. I spent the past few weeks making it better, and in this video I'm going to answer all your burning questions like, what does it sound like when 60 hard drives spin down at the same time? Or how much power does this thing suck down? Yeah, I'll get back to that, and a bunch of other questions later in this video, but first, I mentioned in the last video, the HBAs, these cards that connect the Pi to all 60 drives, were running really old firmware. With that firmware, when I tried running the drives in RAID 0, one of the cards would reset anytime I wrote more than a few gigabytes of data. Worse, when the card came back up, one or two drives would just be missing. I had to reboot the Pi every time I tested the Petabyte, and that got old fast. The Broadcom engineers told me I should try upgrading the firmware, but that led me down quite a rabbit hole. First, I tried it on the Raspberry Pi, but it kept giving me signature validation errors. So then I was like, I have this Windows PC, I can pop the cards in it and upgrade them there. Oh, but it is never that easy. Quick sidebar. You know how sometimes on LTT the writer for the video appears on set with Linus to explain something? Let me tell you, there are little parts in these videos that might be 5 or 10 seconds long, or they might not even make it to the final cut, but it takes days or weeks to figure them out. Well, this was one of those times. I grabbed my HP desktop and popped one of the HBAs into it. In Windows, I downloaded the latest version of StoreCLI, Broadcom's utility for managing their HBAs. Since the card was running on super old version 5 firmware, I tried first upgrading to version 12, and that worked. Version 14 worked too. But then I tried upgrading to versions 15, 16, 17, and 18, but none of those worked. I got that same firmware flash image invalid warning that I got on the Pi. Well, that was weird. So the next thing I tried was downloading an old version of StoreCLI from April 2020. The Broadcom engineers mentioned that they often updated StoreCLI alongside new firmware versions, and maybe using an older version would help. And what do you know? It did. I was able to upgrade to version 16, then 18, rebooting between each update. Then I tried using the latest version of StoreCLI again for the version 20 upgrade, but I got that same image is invalid warning. So dropping back to the old StoreCLI version, I was able to complete the cycle and upgrade all the way to the latest version 23. I pulled the second card out, plugged it in, and decided to just try the really old version of StoreCLI to update to the latest version, version 23, right away, and that actually worked. So I popped the third and fourth cards in, flashed them, and plugged all the cards back into the Pi. Heck, I might have just been able to do all that with the Pi if I'd known to use an older version of StoreCLI. But that was done, and after I booted PetaPi up, I created a Btrfs RAID 0 array again, and this time it actually ran a little better. Most of the performance numbers were slightly better on firmware 23, and what's better, I still got random cards that would reset under load, but they would recover all the hard drives every time, so the array could still work without having to reboot the whole machine every few gigabytes. But that's not good enough for me. You all gave me a lot of suggestions. One of them in particular would help me rule out power issues at least, and that was forcing the Raspberry Pi back to PCIe Gen 1 speeds. Using this script, I forced the Pi's bus to run at half speed, which is still plenty for my gigabit network connection since half speed is 2500 megatransfers per second. After I confirmed all the cards were running at that link speed, I ran my benchmarks again, and of course, they were all slower. But that's just when running locally, not over the network. But before I tried a 60 drive network copy, I wanted to see what the breaking point was at PCIe Gen 2 speeds. So I tested 15 drives, then 30, then 45, and I found out that RAID works great with 1 or 2 HBAs, but when I tried 3 HBAs with 45 drives, that's when one of the cards would start to reset under load. I also swapped around cards during that testing to make sure it wasn't just one bad card, and it wasn't. So now I can confidently say that you can do up to 30 direct attached drives on a Raspberry Pi at full PCIe Gen 2 speed, but after that it gets a little dicey, at least with the adapter I used. The USB 3 cables these things come with can be a little flaky, and they're not even rated to route PCI Express traffic, but heck, a Pi isn't really rated for 60 hard drives either. Anyways, the next question was, can I get all 60 drives working stable at PCIe Gen 1 speeds? And the answer is yes. I copied about 70 terabytes of data over the network and got about 70 megabytes per second write and 100 megabytes per second read. No cards were resetting at all under that speed. Just to be complete, I also ran all the tests with a 2.2 GHz overclock on the Pi, since the giant fans inside the Storinator kept it down to like 35 degrees Celsius, and that did make things a lot faster. Network copies were up to 80 to 100 megabytes per second write, and maxed out the Gigabit Ethernet connection for reads. So heck, if you just wanted a massive low power storage server and don't need to write more than 70 or 80 megabytes per second to it, then this might not be the most insane idea ever. Speaking of power, that was one of the questions people asked the most. How much power does it use? Well, full out when I was running a benchmark in RAID 0, about 512 watts. At idle, with 60 drives, 502 watts. But during boot, while it's spinning up 15 drives at a time, the maximum power draw I measured with a kilowatt was 632 watts. And that's not bad, all things considered, but that is about 350 kilowatt hours of electricity per month, and here in the Midwest, running this 24/7 costs about $45 a month in the summer and $30 in the winter. But if I just run 15 drives, the PetaPi only uses 200 watts. So if I set up the array in multiple VDEVs and let some of them spin down, I could definitely save some money here. There were a bunch of other questions too, like how much does this thing cost? Well, assuming you can get a Raspberry Pi right now, this whole system, including all the drives and HBA cards, would run you about $50,000. And someone even asked me why I didn't do a petabyte of flash storage like Linus did recently. Well, that would cost at least $500,000, so yeah, not gonna happen. How much does it weigh? Well, about 300 pounds, which is a lot more than I can lift. In fact, before I move it, I have to take out all the hard drives to prevent damage. Could I use hardware RAID cards instead of HBAs and have them set up 4 separate RAID arrays, then have the Pi join them together with software RAID? Yeah, maybe, but that would still probably run into the weird bus problems with my PCI Express switch. Could I use one HBA and a SAS expander, which would basically multiply how many SATA drives I could use with one card? Yes, in fact, the Broadcom engineers even suggest I try out this card if I wanted to do that, but I didn't. Maybe something to test in the future. Could I run multiple Raspberry Pis and split up the hard drive so each Pi just has 15? Yes, I could definitely do that. In fact, I'm working on a Ceph cluster video using this new Pi cluster board soon, so subscribe if you want to see it. But clustered storage is a whole different ball of wax, and getting all that running inside one Storinator chassis wouldn't be as fun. Could I upgrade the networking on the Pi to 2.5 or 10 gigs? Yes, actually, but I've actually done a lot of testing with that in the past. The problem here is because the Pi just has that one PCI Express interface, with most NICs, interrupts cause the real-world throughput to stay below 100 megabytes per second when you're using Samba or NFS. So I could get a 10 gig link, but file copies are still going to be about the same. Almost every test I've done, I've hit the edge of the Pi's performance envelope. But hey, I do that so you don't have to. Not everyone needs a 10 gig network or heck, even a petabyte. What happens in Linux when you have more than 26 hard drives? It just starts over and adds another letter, so you get like SDAA and SDAB. The final question is, what name did I pick? And obviously if you're this far, I stuck with PetaPi. It just feels nice and simple, and it's a good shortening of Petabyte Pi. Some other names people suggested were Petabyte, Petabyte, P3, the PP or the big PP, and Petaphile. Yeah, we're definitely not going to use that last one. All right, so if you have any other questions, comment below. For the next few weeks, I'm going to replace the guts of the server, pull all the drives, move it into my rack, and get it set up for the long term. And my next video on it will have a special guest appearance, so make sure you're subscribed for that. This project surprised me. I knew there was a good chance I could get a petabyte of storage on a single Pi, and I did. And I even found a way to make it stable in RAID. But would I recommend it? Well, if you don't need more than 70 megabytes per second, go for it. But most people who want a giant storage server would probably want to stick with a better server CPU. But heck, who knows what the future holds? New ARM SBCs with the Rockchip RK3588 can have up to 7 lanes of PCI Express. That's a lot more bandwidth. If the next Pi generation can do anywhere near that and still run stable, running a PetaPi in production might not be such a wild idea. Until next time, I'm Jeff Geerling.